Hi students, this is Chapter 7, Lesson 2. The topic of today is how to solve addition equations. In this lesson, we're going to start to learn the formal process, the steps that you should be writing down to show your work when you're solving an equation. And even though a lot of these equations you are going to be able to look at and you'll be able to think, hey, I can solve this in my head, I really want you to be following the process, showing your work. Because, like I said in Lesson 1, introducing this chapter, eventually in math you're going to run into things that you can't solve in your head. You have to be able to fall back on this process that we're going to learn today. Okay, let's get started. First thing I want you to write is that an equation is like a scale. An equation is like a scale. Yesterday we learned that an equation is two expressions that are equal. You've got an expression, an equal sign, and another expression. That makes an equation. But the way I want you to think about an equation is this. One of these scales that you've probably worked with, okay, a balance scale. So it's one of these scales that looks like this. Okay, quick sketch. So it's one of these scales where you can put stuff on this side of the scale and on this side of the scale, and if it's balanced, it looks like that. If one side is heavier, the scale is going to do this. Okay, but when it's balanced, it's going to look like this. And that equal sign is right in the middle of this scale. So something, an expression on this side, an equal sign, and an expression on this side. That's the way I want you to think about an equation always, is that it's something equal to something and it's in balance. Okay, today we're going to build a scale model for an equation, and on this side of the scale, I'm going to have 5 counters representing 1, so I've got 5 counters. Each of those counters represents a 1. On this side of the scale, I'm going to put a cup and 3 counters. Now this cup, it's a special cup that's weightless, so there's no weight to the cup at all, but in this picture, it's balanced. You've got 5 counters on this side for a total of 5, you've got 3 counters on this side for a total of 3, and this cup, that's a magic cup that doesn't weigh anything, that cup is actually going to represent our variable. So I'm going to put an X on this cup. That represents some unknown amount of counters are in that cup. So down here, so this is a model. I'm going to translate this into math. 5 counters equals, on this side of the scale, I've got a cup with something in it, and then the cup plus 3 counters. So this equation comes from that model, and it's balanced. It's not tipping up on one side versus the other. It is balanced. So I know that you're looking at this and probably thinking, well, I know how many counters are in that cup because it's balanced and it's a simple equation. But this gets to what I talked about, the process for showing your work. So the first thing, we're going to talk about another property right now, and it's called the subtraction property of equality. The subtraction property of equality. what this property says, what it means, is this. The subtraction property of equality means you can subtract the same amount from both sides of the scale. Or the equation. Imagine, so now I'm going to go back to the model. Imagine I took one counter off of this side and I took one counter off of that side. Well, because I reduced them by this exact same thing, the exact same amount, it's going to stay balanced. That's what the subtraction property of equality tells you. You can subtract the same amount from both sides, and I think you can probably tell by that explanation, the scale would stay like this. If I took one counter off of one side and one counter off of the other side, it would stay like that, completely balanced. Okay, so the scale would stay balanced. And the equation would stay balanced. Okay, this follows from the subtraction property of equality. If you're subtracting the same amount from both sides, it's going to stay balanced. Okay, the next thing we're going to talk about are something called inverse operations. So in math, we've talked about this a bunch of times. When you hear the word operations, I'm hoping that you think add, subtract, multiply, and divide. Those are the operations in math. Inverse operations are operations that undo each other. So I'm going to write that over here. It's kind of, a lot of kids like to think of that as opposite, but the word is inverse. Inverse operations. Inverse operations are operations that undo each other. Okay, operations that undo each other. And most of the time, kids can guess what the inverse operations are. If you have addition, the operation that undoes addition is subtraction. If you have subtraction, the operation that undoes subtraction is addition. If you have multiplication, the operation that undoes multiplication is division. And if you have division, the operation that undoes division is multiplication. So this idea continues throughout this whole chapter. The idea of inverse operations, and here's what they are. Okay, when we're solving equations, we are going to be talking about what is the inverse operation of what's happening. So here is what it looks like to solve addition equations. So I'm going to go back to this equation right here. 5 equals x plus 3. And I'm looking at my variable. I want to get the variable all by itself, because if I can get just the cup on this side of the scale and something on this side, well, then I figured out what's in the cup. So I look at my diagram and my equation, and I see that x, some unknown number in the magic cup, 3 is being added to it. 1, 2, 3. I want to do the inverse of adding 3. Well, what's the inverse of adding? Is multiplying. So because 3 is being added to my cup or variable, I want to undo that with the inverse operation. What's the inverse of add 3? That is subtract 3. So I want to show that I'm taking away 3 from this side of the scale or of the equation, but I also have to take away 3 from this side. Otherwise, scale would not be balanced. So showing my work looks like that. I took away 3 from this side of the scale, and I took away 3 from this side of the scale. And then I'm going to show what happens when I do that. So actually, let me go back to subtraction property of equality. I just showed that right here. I showed that you can subtract the same amount from both sides. Now I'm going to look at just this side. If I have x plus 3 and I take away 3, 3 take away 3 turns into nothing or 0. So on this side, I'm left with just an x. On this side, 5 take away 3, I am left with 2. So this is how you're going to be showing your work today, using the subtraction property of equality. Even though I know that a lot of you, for a lot of the problems today, you're going to be able to look at that and quickly go, oh, the answer is 2. I want to see this part, okay? Follow the process. Follow showing your work. Copy the equation. Show that you're using the subtraction property of equality, keeping things the same by taking away the same amount from both sides, figuring out what happens on this side, you're left with x. What happens on this side, you're left with 2. Okay, so the last thing we're going to talk about is how do you check your solution? And again, this is an easy, simple equation. I promise you, though, as you continue in math, you're going to get numbers where you can't do it in your head, and you've got to fall back on this process. Okay, so to check how do I check if this is right? So what you do is you write down the original equation. The original equation was this, 5 equals x plus 3. Okay, so you write down your original equation. Then you replace the variable with what you think is the answer. So I'm going to write replace variable with the solution. What you think the solution is. So I think the answer is 2. So now I'm going to replace the variable with a 2. So what does that look like? 5 equals 2 plus 3. And that statement has to be true. And again, this one's a simple equation. You're all looking at that going, yes, that's true. 5 equals 2 plus 3. That is how you check to see if your answer is correct. So, big ideas today that are going to continue throughout this chapter. An equation is like a scale. Something equal to something else. You're looking at the variable side where your cup is and figuring out what's happening to it, and you are doing the inverse of that operation. 3 is being added. I want the inverse of adding, which is subtracting, because I want to get that variable all by itself. I want just the cup on that side telling me the amount that's in the cup or in the variable. All right, that does it for lesson 2. Again, please show your work following what's in this pink highlighted rectangle. Here is Chapter 7, Lesson 2's Hidden Treasure. If you can solve that puzzle, and you've got the work and all the Chapter 7 notes, you could be the lucky winner. I will see you soon for Chapter 7, Lesson 3.